My name is Kelly Pavel, Technical Manager for Infino Engineering, LLC. And today I want to talk about Waterhammer and steam and condensate systems. Talk about the safety and reliability issues that are related to Waterhammer. This will be a multiple presentation in three parts, and this is the first part, or part one. Waterhammer is not only a system issue, it's a safety issue. So the thing is, we have to understand Waterhammer corrected because it presents a safety issue for plant personnel. Understanding the nature and severity of Waterhammer and steam and condensate systems will allow the facilities to avoid the destructive forces of Waterhammer. In this presentation, we'll understand what causes Waterhammer. And the other thing, the important part, changes needed to prevent Waterhammer. We talk about system designs, system engineering, installation, operation, and of course, steam system startups. Unfortunately, 82% of the steam systems in North America are experiencing some type of water hammer. It's very unusual for our engineering team to walk in and we ask the question, do you have water hammer? And the response is no. 82% or more, the plants say, yes, we do have water hammer. Then we always hear the statement, water hammers is unavoidable and a natural part of steam and condensate systems. This is entirely false. You should never have water hammer. Zero water hammer. And water hammer is an international issue. It doesn't matter if we're in Asia or South America or Europe. Plants are experiencing water hammer throughout the world. So it's really an international issue. Why does water hammer occur? It can occur in steam or condensate systems. In steam systems, water hammer can occur from too fast of a startup or energizing the steam system. You have to understand what is the proper time frame for starting up a steam system. So you have to have a time frame. So I've been on startups that have taken days to start up a steam system. Steam trap stations on steam lines that are shut off and not in operation. Too many times we come in, we find steam traps that are shut off and not in operation. Lack of steam trap stations in strategic locations. Where do you need steam trap stations in the system? Why does water hammer occur? Condensate systems main lines, two phase flow. The system contains two states, a liquid, condensate, and the vapor or flash steam, which is generated from the process, or hot condensate traveling from a higher pressure to a lower pressure. Two-phase condition exists where condensate coexists with generated steam or flash steam. Condensate line velocity should never exceed 4,500 feet per minute. So, condensate coming off this process here is going to be a higher temperature. Passes through a drain device, let's say a steam trap, and then flash will occur, which is this white bubble symbolizing flash. And then flash will come up here in the condensate line. So in condensate systems, we're always dealing with two-phase flow, and we have to accommodate that. The other thing is condensate line velocities can never exceed 4,500 feet per minute, otherwise we will get water hammer. Condensate removal for process applications. Condensate that needs to be removed as quickly as condensate is formed in the process. Undersized or improperly sized condensate removal devices that allow condensate to back up into the process unit will cause water hammer. So undersized steam traps, undersized steam valve, condensate valve removal device will cause water hammer. The other thing is we have high condensate line pressures that reduces the P2 or the outlet pressures of our drain devices. So we have to understand the pressure in the condensate line. Eliminating water hammer change must occur. You know, abnormal operations or pipe moving, banging noise, pinging noise, component movement. Those are abnormal operation. The normal operation, there is no noise, there is no movement. Possible. So, the normal operation, no noise, no movement. Water hammer, the results, in steam or condensate line fit, pipe welds breaking, flanges, supports being broken, guides, elbows, damage to flow metering units, all common, you know, results of water hammer. Valve failure, body failures, cracked valve bodies, and heat exchanger tube failures, gasket failures. We even had a shell ruptured from a severe water hammer. Pressure gauge failures, internals damage, pump failures. The other thing that we get involved with is not too much of water hammer, but pump cavitation, steam trap station failures, steam trap bodies failed, check valves in the steam trap station. Root cause analysis, steam traps do not withstand water hammer at all. Zero tolerance for it. So, and root cause analysis, you're always finding that water hammer caused problems. Evidence gathered while conducting root cause analysis on steam and condensate components suggests water hammer causes about 67% of the premature failures in the system. So, if we don't get corrected the water hammer, it's just going to create more issues and destroy our components in the steam and condensate system. Come to our website, www.invenoeng.com, and there's 70 best practices there, 28 articles, and 24 instructional videos. And there is a technical paper on water hammer, and you can read through the technical paper as going through the videos. Our approach is short term, we do steam system assessments, steam system balancing, steam system reliability studies, and steam system engineering training, where we train people on steam systems. Long-term impacts, we do implementation engineering, project design, project management, full engineering support, and for steam and condensate changes. This is our contact information. You have any questions regarding water hammer, please contact us here. I'd be more than happy to help you or consult with you. Anytime you have questions on steam or condensate, please contact us. We're more than happy to discuss anything regarding steam and condensate systems. Thank you for your time. Have a great day.